All right, hey class. So I just finished recording the homework 3 video, so watch that if you need it. But now we're doing the homework 5 worksheet, and this is probably more important than homework 3, honestly. I think most of the questions on the quiz are going to be these shaded area kind of problems. We call these composite figures, right? So make sure that you're familiar with these. These are going to be kind of big on the quiz. Let's start with number 1. So when I look at number 1, I definitely see, a shaded area that could best be approached as a square minus a circle, right? If I found the area of the square, that would give me everything. It would give me all the area everywhere. And so the idea is, well, do that. Find the whole thing's area and then just subtract away the part you don't want. So if I just kind of do that and start subtracting away all this inner stuff, then I'd be left, of course, with only those outside corners, which is what I want. So that's definitely the way to do this problem, is as a square minus a circle. So now I'll plug in my formula. Ooh, that's a little big. Plug in my formulas. The square, I just treat it as a rectangle usually. Just say base times height. Then you'll subtract from that the circle, so pi r squared. And now the base and height of the square are 8 and 8. So it's 8 times 8. Then the radius of the circle, I don't know, maybe it's a little tricky, but not really. If you look at it, the radius could be here, up and down, or another one here, up and down. I don't think it's too tough to see that the side of the square is equal to the diameter of the circle. And if the diameter of the circle is 8, then the radius must be 4. So we can substitute 4 in. So that's going to give me an answer of 64, that's the area of the square, minus 16 pi. That's the area of the circle. Again, on the quiz, I'm going to go ahead and ask you for both. I'm going to ask you for the exact answer that still includes pi, and I'm going to ask you for the approximation. So of course for the approximation we got to go back to our calculator, and what are we doing? Clear everything. How do I do this on a stinky old calculator? I guess we're typing in 64. We're saying minus 16 times 3.14159. And then we say equals, and I think our calculator will do it in the right order. So 13.73. I'm going to jot that down. And then I'll show you another way to do it that maybe would feel a little more comfortable. Where's my calculator? Here it is. Alright, so we could do 16 pi. So if I went 16 times 3.14159, then I know that's right. And then I subtract from that 64, and I know it's going to try to tell me the answer is negative, but I just ignore the negative. I know that I did it in the wrong order. I did 16 pi minus 64 instead of 64 minus 16 pi. But the answer will still be 13.57. Just ignore the negative sign, because you know you did it in the wrong order on purpose because it was easier. That's just a trick with these 4-function calculators that might make this a little easier for you. Is just don't worry if you get a negative. It's just because you did it out of order. All right. But anyway, make sure that you're able to come up with both the exact answer, still involving pi, and the decimal answer. And by the way, both of these are square meters. Alright, now we can do number 2. And number 2 is another subtraction problem. We're going to do the rectangle, which is too big, and then subtract from it the triangular piece that we don't want. And that's it. That's all there is to this. So the rectangle is base times height. Then we'll subtract from that 1/2 times base times height for the triangle. So we're ready to substitute. The base and height of the rectangle are the 10, which goes all the way across, and the 6, which goes up and down. Then for the triangle, we have 1/2 times the base, which is 7, times the height, which is 6. All right, I'm hoping 10 times 6 is easy enough. That's 60. And what do I do over here? Probably I would do 6 times 7. You guys should know off the top of your head that's 42. And then take half of that. So half of 42 is 21. And then 60 minus 21 is 39. And it's 39 square inches. So that's it. Next couple. So 3 and 4. So 3 is another one of these that we could do a couple ways. Some of y'all might prefer to look at this and say that you're going to slice it right here, creating a rectangle, a rectangle, and a rectangle, and you're going to do it all by addition. So you'll go part plus part plus part. And that's fine if you want to do that. It's not what I'm going to do. I'm going to look at this thing and think that what I've got is one big rectangle right here that just happens to be missing a piece. So I'm going to do this problem as a rectangle minus. It's a square technically because it's 4 by 4. I'm going to just keep calling everything a rectangle though, because it's technically true. So we're going to do big red rectangle minus little green square. So this will be base times height minus base times height, where the first base times height is the red rectangle, so it's 12 by 8. Then we'll subtract from that the little green square, which is 4 by 4. But that's it. So now we know the red rectangle is 96 square units, and we can see that the square is only 16 square units. So if you subtract, you're left with 80 square inches. Okay. So the next one, I'm doing this one as a subtraction problem too, because when I look at this, I see a rectangle right here, and then a semicircle that's missing. So to set this up, I'm thinking I need a rectangle minus a semicircle. So for the rectangle, it's just base times height. And for half of a circle, well, if a whole circle is pi r squared, then a semicircle must just be 1/2 times pi r squared. So now the dimensions of my rectangle are 6 by 13. And then the only dimension I ever need for a circle, or even a half circle, is its radius. So we can find this radius by remembering that this entire dimension is the same as the 6 from down here. So that whole thing is 6, and then of course the radius chops that in half. So that radius must be 3. Okay, so again, if you're trying to give me the exact answer, well then 6 times 13 is 78. Then we'll subtract from this. Let's see. 3 times 3 is 9. So I'm calling it 9 pi over 2. And no, I wouldn't clean that up in any way. This is the best possible answer right here. And you'll call those square yards. So if you've got an answer that's a whole number, and then another part that involves pi, maybe it's a fraction too, that doesn't matter. That's still how I'd want you to leave your answer. So 78 minus 9 pi over 2. But again, I will ask you to also give me a decimal. I think I will. So I'm going to do the same trick. I'm going to calculate the 9 pi over 2 first, and then subtract 78 from it, and then just ignore the negative. So looking at our calculator, I do want to have the pi button, so I'm going to bring that back. Alright, so I said I was going to do 9 times pi. 9 times pi. Now you gotta say equals, divided by 2, equals, and then I want to do 78 minus this number, but instead I'll do this number, minus 78, and it'll come out negative, but I'll just ignore the negative. So 63.86 should be our rounded off decimal. 63.86. And these are all still square yards. So that's four. First four done. What else is there? 5 and a 6. Great. Looking at 5, again, I would say the only approach that even makes any kind of sense is to just do this big outer rectangle and then subtract away the slightly smaller inner rectangle. So I see this as another subtraction problem. I'll even skip the drawing this time and just say our area is going to be base times height minus the other base times height. So for the larger pink rectangle, it's 11 by 8. And for the smaller green rectangle, it's 9 by 6. So we're looking at 88 square yards minus 54 square yards. Can I do this in my head? I think I can. Looks like 34. So that shaded area is 34 square yards. All right. So this next one, it's another one where I would subtract. You can pretty clearly see that we're going to be working with the big circle on the outside. That circle right there is what I'm talking about, of course. And then if you want to get these three shaded areas, then after finding all the area of that entire red circle, you'll take away the area of this green triangle. And then the only thing left would be those three shaded areas. So that's the approach. We're going to definitely do area equals whole entire circle minus triangle, which means we're going to be doing pi r squared minus 1/2 times base times height. So the radius should be 8, because of course it's only half of the diameter. Then the base of our triangle, well, the only dimension we have is that 16. So we'll let 16 be our base. We've got to figure out the height, but if you look closely, you can see that the height falls straight down from the top of our triangle down to the middle here. So we're going from the center to the edge of the circle. That's going to be the radius, again, which is 8. So the radius of our circle is also the height of this triangle, which means we can figure this out. So I'm getting an area of 64 pi. Let's see. If I just do half of 16 to get 8, then 8 times 8 is 64. And that's it. I don't know how many times I've seen people try to subtract and say that the 64s like go away and the final answer is pi. Like, that's just not true. It's 64 pi minus 64, and you can't touch that in any way. You just leave it as 64 pi minus 64 square feet. And again, to drive the point home, to anyone who thinks the 64s would cancel and give you an answer that's just pi, well, let's go see what we get as a decimal from our calculator. So I clear everything, and so we do 64 times pi, we get 201. So now if you subtract 64 from that, you're still left with 137.06. So that's a far cry from pi. Remember, pi is only worth 3.14, so this is a heck of a lot more. So be pretty careful as you work these problems. Try to keep your answer as accurate as you can, blah, blah, blah. Moving on. All right, so 7. For 7, let me get back my little compass guy. And again, I'll say, to do this problem, we're pretty much obviously gonna think about a whole entire circle and then just chop that in half to get the semicircle. So right here. We'll take just that top half. Then you should be noticing that up here, these two cutouts are little semicircles again. So you got a semicircle there. We could draw another one here if we really needed to. But hopefully you guys are getting the gist. Basically, our funny little shape up here, that shaded area is just a circle minus two more half circles. So I'm setting up an equation where I'm doing what? A half circle minus a little half circle minus a second little half circle. So this shouldn't be bad. I'm just going to be doing pi r squared and chopping that in half. Then I'm going to do pi r squared, chop that in half again, and then do it one more time. So for the big red circle, if this radius is 2, then this radius over here is 2. So the radius of the whole circle is 4. So we're doing 1/2 pi times 4 squared. And then the little guys all have radii of 2, so it'll be 1/2 pi times 2 squared minus 1/2 pi times 2 squared. So doing this, 4 squared is 16, half of 16 is 8 pi. Then we're subtracting from that, let's see, 2 squared is 4, chopped in half is 2 pi. And the other one's the same, another 2 pi. So if you subtract 2 from 8, you got 6. If you subtract 2 from 6, you're left with a final answer of 4 pi. Now why am I combining this time? Well, because they all have pi. They are all like terms. You can't subtract when one of them is a whole number and the other one is pi. But these are all pi's, so you can do the math here like you would do any other math. So that's going to be 4 pi square meters. And that might be the end of this. Nope, one more. 2 more. All right. So 2 more area problems, then you guys can be done with this lesson at least. And I feel like we did this in class, but that's okay. But for this problem, I would draw a line here, forming this triangle, and then I would treat this problem as one big rectangle minus a triangle. So it's going to be 1/2 b1 plus b2 times the height, and then we'll subtract from that this triangle that we're cutting away. So 1/2 base height. All right, hopefully when it comes to dimensions, you're feeling good about this. Remember, b1 and b2 are the bases, which means they have to be the parallel sides, which means they're 18 and 20. Then the height has to tell you how far apart those two bases are. That's this 22. Now for this one, to find the base of the triangle, we're going to want to use this dimension right here. And hopefully you can tell that that dimension plus this piece would be the total vertical change of 22. So adding up the 4 and the 12, I get 16, and if I subtract 16 from 22, I'm left with 6. So that should be the base of our triangle. Now we also need a height though. And this is the problem that just had a typo. There's just not a way we can figure out how tall this is. It's not related to the 18. It's not related to the 20. You just can't do it. So I don't remember what I said. I think I told people to just treat it as 7. It seemed to me to be a little bit longer than the base. So I'm calling it 7. And that's a typo on our part. If we give you a quiz and there's no way to find the dimension, that's on us. So just tell us, hey, I think you made a mistake here. We'll figure it out. We'll fix it. Anyway, so what am I doing? I guess I'm doing half of 38 times 22. And over here, I guess we're doing half of 42. So So I just can't do that in my head. Not quite, at least. So I see my calculator is actually a bit in the way too. Move it over here. All right. So to calculate, we're going to clear everything. We're going to do, sure, let's just do 38 times 22. We've got the calculator, right? So 38 times 22 is a big number, and then we're just dividing by 2, so just do that. So it's 418 apparently. Then we want to take away from that 21. So that looks like it's going to bring us down to 397. It doesn't hurt to double check, so I'll double check. We're doing 418 minus 21. Yeah, 397. Square meters. All right, so we're almost done. We can do this last one here. And so looking at this, I would definitely break this down to where I've got one big rectangle in the middle, and then the top is a semicircle. Hold on, my computer's being weird. I think I'm okay now. Something else got a little bit weird. Not that I know how to fix it. Okay, gonna ignore it. To do this problem, I would look at it and I would recognize that they've given me a nice big rectangle that I can handle. Oh, that fixed itself. And then what they're doing is they're adding on these two semicircles. This is definitely an adding problem. And I think every other problem we've looked at has been a subtraction problem. So it's good that this time we're seeing a problem where we actually want to do the area of this big rectangle, then we want to add on the semicircle and another semicircle, which, by the way, two semicircles just make one whole circle, right? So there's no reason kind of doing them separately. You know that's really one big circle. So okay, let's write a formula where the rectangle will be base times height, and the two half circles, that's just one circle. I'm just going to do it as one circle. All right, for the rectangle, my dimensions are, well, let's see, it says right here 15 and the height is 5. So the dimensions are 15 by 5. Then for the radius, we got to be a little tricky here, I guess. It's these little bits here are 3 each, and that makes them add up to 6, which means this distance here in the middle would be 15 minus 6, which leaves 9, which actually means that our radius is 4.5. I don't love that. I wouldn't do 4.5. I would do 9 divided by 2. It's actually easier, okay? So if I do all this, I'm going to get an area of 75. And then the reason I think this is easier is because I can now square 9. I get 81 times pi all over 2 squared, which is 4. And that's not bad, that math. I don't know why I put an equal sign here. It's supposed to be a plus sign. But giving me an answer of 75 plus 81 pi over 4, I don't know. That seems like the best answer. If you guys want a decimal, that's fine. But you got to give me this first. And then your next answer can be an approximation. And let's see what it would be. So we clear everything. I'm going to do 81 times pi. Hit equals. We're going to divide that number by 4. Hit equals. Then we're going to add to that 75 more. So I'm getting 138.62. So that's it. There's your answer, both in its exact form and as a decimal that we rounded off. I want to put the units back in this box. There we go. So there's everything you need. And that actually was the last one too. So that's page 5 done. We move on to 7 next. 7 is where we're going to be revolving these two-dimensional shapes to create three-dimensional shapes. So hopefully you'll be feeling good about that. Anyway, I'll see you in the next one. Bye.